Hi guys, welcome to this second part of our lecture series on predicting total expected cases for given day. So guys, we learn about simple linear regression in our last lecture and also so that it doesn't solve our purpose for given problem. In case you wish to look forward for the data set and if you want to practice the code at your own, you can always email me at snehiljoshi2020 at gmail.com. I will be happy to share the data set. So let us start with this particular section and uh, as we saw in our linear regression model, you can view the plot that we created. This model doesn't fit and appropriate for given problem, and we also saw that the relationship between days and total cases are not linearly related. The relationship is basically parabolic, that is visible where actual data is represented in blue dots. And so now our choice is to fit the model using higher degree of polynomial. We will start with polynomial regression of degree 2 first and check how fit and close the prediction is compared to actual data set. So let us write code to fit the model using polynomial regression. First of all, we will import pandas and numpy libraries, and we will also use pyplot module of matplotlib library. Next step is we read our dataset CSV file and store it in data frame df. Using head function, we check data frame, and now our data frame is ready. So let us extract our independent and dependent variable using data frame. Here we are willing to predict total cases using total days. So days will be our predictor variable, and so we will store it in X, and the prediction variable is total cases, and that will store it into Y. First of all, we will fit the polynomial regression model using degree 2. So we import polynomial features class from pre-processing module of sklearn library, and we create an object poly underscore regs1, that is polyregs1, from polynomial features class with degree equal to 2 as shown in line number 32. First of all, we will transform our indirect variable x using fit transform function and obtain new data type x1. Next step is fit the polynomial regression model using fit function. We have created lm2 as polynomial object from the linear regression function, and finally we fit the model by passing x1 and y, which are predictor and target variable respectively, to the fit function. Let us visually check and see that how fit the model is by comparing scatter plot obtained using actual total cases shown in blue, and our predicted model is in red. As shown here, we plot scatter plot using actual values of data set x and y as shown in line number 60, and simultaneously we also plot polynomial regression line in red using past parameters x, which is predictor, and obtain predicted values of total cases using predict function as shown in line number 61. So we add title, x label and y label, and finally we'll display that. So you can see that it is a parabolic representation of the plot, but it does not match exactly with the actual data set. Now, if you look at this plot, it is visible that the plot is not best fit. However, it is representing polynomial parabolic curve, but doesn't address the actual data set displayed as blue dots. Between day 20 and day 30, it is overfit, and between day 5 and 15, it is underfit. Again, from day 31 onwards, it is highly underfit. So now let us check its performance and predict for day 30, 31, and 32 and check with its actual cases. Here we can code to predict for day 30, 31, and 32, and we have corresponding output too. If you look at the line 97 of code, we predict using predict function and pass value 30 to fit transform function. In line 98, we display the value of prediction obtained. Its corresponding output is visible in output screen as shown in line number 219 with value 1327. This is prediction for day 30th. However, actual value is 1250 and that is a known value. So similarly for day 31, we predict as shown in line 101 and 102. Here we obtain prediction shown in output window line 220 is 1464. However, actual known value obtained for 31st is 1397. Finally, for 1st April, which is represented as day 32, we can predict it as shown in line number 104 and 105, and the predicted output is 1608 as shown in line number 221. If we compare it with the actual data which is known to us, the actual case for 1st of April, that means for day number 32, were 1834. So, like it is below our estimation or below our value that we predicted. So, we need to enhance this model, but how to enhance it? Okay, to enhance this, instead of considering degree 2 for polynomial regression model, we consider degree equal to 3. So now let us fit the model using degree equal to 3 and then check the actual data and predicted data using plot. So here is a code to fit the polynomial regression model for degree equal to 3. We already have our predictor and prediction values, variables x and y respectively. Hence, using it, we will fit the model for degree equal to 3. Once the model is fit as shown in line number 43, we will use this model to plot the scatter plot, which will display actual dataset in form of blue dots, and along with it we will draw our polynomial regression curve in red, which will visually give us an idea how far our model is a good fit. Here is the code to plot the curve, both scatter and regression line together, and we also display the curve as a result of this code. As you can see the plot for degree equal to 3, it is very much visible that our regression line displayed in red line is highly close and following the actual cases. In a next slide, we compare both plots obtained using degree 2 and degree 3. Okay, here is the comparison of both regression plots obtained for degree equal to 2 and degree equal to 3 for polynomial regression model. Your left side is the plot for degree equal to 2 and your right side is the plot for degree equal to 3. It is clearly visible that the model obtained using degree equal to 3 is predicting highly close to the actual virus cases and very well fitted. Hence, we adopt our prediction model, which is based on polynomial regression with degree equal to 3. Let us obtain the intercept and coefficient values for this model and display the final model. As shown here, we obtain intercept and coefficients using this code, and here we obtain the value of intercept and coefficients. Let us create our polynomial regression model using this intercept and coefficient values. As shown here, the model is model to predict cases for given day will be sum of intercept with all coefficients in order multiplied by predictor variable starting from the power 0 to power 3. Here, our predictor variable x, which represent days. Hence, if you wish to predict for total cases on 35th day, keep the value 35 in place of days. Other way of prediction is using predict method as shown at the bottom is a two-line code which you can see, and here we are predicting it for 35th day by passing the value of days as 35 to fit transform function. using predict function. So we learn obtaining prediction model development as well as obtaining value using predict method here. So using this particular model, and since we have fit the model, once the model is fitted, and using the predict function, you can just pass on the day value and you will obtain the corresponding cases, predicted cases for that particular day. And you can just check that you predict for a next week, you predict for you 10 days later, and then compare with the actual data set. So that was about polynomial regression. I'm sure that concept of polynomial regression must be very much clear to you, and you must have tried this code and checked the accuracy and efficiency of the model. Uh, like uh, I wish that you try coding this and check with the actual value. However, I would like to mention that this model is based on past data. You need to enhance and update it by adding new record for every day it passes. The more record it will contain, more it will be fit for prediction. Some unexpected events occur, and due to that, if all of a sudden some unexpected event occur, then some uneven data increase, then this model cannot anticipate, and it the like due to that the prediction may vary. Otherwise, it can definitely give good trend and prediction. I would like to say that this is purely for academic purpose. Do not use it for any kind of predictions and spread it in social media. So have a great day, happy learning, happy coding. Take care, stay safe, and stay secure. Good day to you.